I'm Anil Kumar, and here is question number 7 on transformation of functions. Sketch the graph of f of x equals to minus square root of 4 minus 2x plus 1 and then write its domain and range. You can pause the video, answer the question, and then look into my suggestion. Now, as always, as I say, we need to write the function in the standard form. When I say standard form, what I mean is kind of like this. Write with minus 2x first plus 4 plus 1. You should always factor this. So minus square root of, if you factor minus 2, you get x minus 2, right? 4 divided by minus 2 plus 1. So that is the function from where you can easily write down all the transformations and then sketch it, right? So first let me show you a rough sketch, and then we'll actually work on the key values, the key points, and then sketch it, okay? So basically the square root function is kind of like this, right? So when we say negative, so we are considering this. So this negative is a reflection, so this is because of this negative. And then let's consider the other color, which is this one, horizontal. So this is kind of like this, right? After that, let me apply different transformation, and this is, let us say now horizontally, we are going to move 2 units to right. So this is at 2, and then we got come like this, 2 units, and then we will apply the last transformation, which is 1 unit up, right? So 1 unit up is kind of here, and you know, I'm not considering the points, but finally I get this point, which is at 2, 1, right? That helps you to give domain and range. Anyway, that is our approximate sketch. Now to get the real values, what we should do is we can look into the key values, right? So for a square root function, do you know what are the key values? Square root of x we are considering. The key values are 0, 0, 1, 1, right? 4 square root 2 and 9 square root is 3. These are good values to begin with, correct? Now transformations which we need to apply on our function is that the x value becomes negative half. So it is, if we have a coordinate point which is, let us say, x and y here, then what happens to that x and y point? That is what we have to check. So x points becomes negative half, right? And then you have to add 2. Everything inside this function. As far as the y points are concerned, on that they become negative, and then we add 1 to it. So that is the transform point, right? So applying this, we can write down x and y points. So let's work with the x points first. So we have to do negative half and then add 2. So in this case, negative half is 0 plus 2 is 2. Negative half is for 1 is 0.5 minus, so it is 1.5. Negative half of this is negative 2 plus 2 is 0. Negative half of this is negative 4.5. Negative 4.5 times plus 2 is negative 2.5, right? So these are the x values for you. As far as the y values are concerned, we'll make negative of this and then add 1. So 0 plus 1 is 1. Minus 1 plus 1 is 0. Minus 2 plus 1 is minus 1. Minus 3 plus 1 is minus 2. Correct? So when you are graphing the function, make a proper scale. Let us say it is going to be kind of like this as we showed there. But now you know the points, right? So that is kind of important for you. Now you know the points, you can draw a very accurate graph. So let us say 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, correct? So you get your points as 2, 1. So you have 2, 1, right? Then 1.5, 0. So x value is 1.5, and then we get 0. 0 and minus 1, that's another point. minus 2.5 and 2. So this 2 is at minus 2.5 and 2. So when you join these points, you get your graph, correct? Now from here, you can very clearly write down your domain and range, right? So it is 2 and this is 1, correct? So now we can write down clearly domain and range for the function. So the domain here is x belongs to real numbers, where x is less than equal to 2, right? This value, correct? And the range is y belongs to real numbers, and y is less than equal to 1. Is that okay? So that is how you can get domain and range after transformation. Well, remember one thing, you could have got the domain directly from the equation also. Let me show you that method also. From here, we have minus 4 2x, that should be greater than equal to 0, right? So we'll take 4 on this side. So we have minus 2x is greater than equals to minus 4. Dividing by minus, let me do it separately. So we get x is less than equal to, whenever you divide by a negative number, inequality also changes, right? And dividing by negative 2 will give me positive 2. So x is less than equal to 2 is what you get. So you could find domain straight from the function itself, and range also. You have moved 1 unit up, and this is reflection, so it's coming downwards, right? So what we observe here is that we can actually give a domain and range straight from the equation also, but the question is write its domain range after sketching the graph, right? So you need to sketch the graph first and then as we did, right? But this is a very good example. You should go through it once again and understand all the transformations which we have discussed in this particular question. Thank you and all the best.